Today we are going to be in GeoGebra, and first we are going to create a quadrilateral of any kind, and we are going to label our vertices, and you could create a square or a rectangle or an irregular quadrilateral. So we're going to make something a little different. And the first thing we are going to do is construct the midpoint of each side by selecting the two vertices that we want. And then, so we select point A and point B, and it will give us the midpoint between those 2 points. And it pops up right there in black. We're going to do that for every side. And one thing to notice is that I cannot move these points by simply clicking on them, but I can move. They do move as I change where A, B, C, and D are, so they will always be the midpoints of the sides no matter what I do to A, B, C, and D, but I cannot actually move these. And so we will connect these points, and we will label them. So we have points E, F, G, and H, which we connected those to make another quadrilateral. So we have quadrilateral A, B, C, and D, and then we have quadrilateral E, F, G, H. And E, F, G, H is formed by the midpoints of each side of quadrilateral A, B, C, D. So we can make some measurements here. We can measure that side and this side. And something that I noticed right away here is that these are the same length. They're equal. And so I would say that they'll be equal all the time. If they're equal right now, why wouldn't they be equal all the time, have equal measurements? Or you could say that the sides would be congruent all the time. And so I can test that by moving any of my 4 vertices and seeing that they are always the same, even if I make this concave or convex. So they're still the same, and they're changing, but they are always equal to each other. And so you can also do a different measurement where I can just click on the side or the segment that I want to measure. And so these are also the same length right now. And so I would say that, let's say the same thing, that these 2 sides are always going to be equal as well. So EH is going to be congruent to FG. And I can test that by clicking and dragging each vertex. And again, these are changing, but they're staying equal to each other. They're staying congruent. Same thing here. They're staying congruent all the time. So that is also true. So if I know that these opposite sides are equal and these opposite sides are equal, quadrilaterals that I know that have those characteristics are squares and rectangles, very simple versions. And they're also parallelograms. So I would say that this could possibly be a parallelogram. And so a very easy way to show that is to show the slope of each side, or the opposite sides that we're looking at, and see if those slopes are congruent. And then that means that our lines are parallel if they have the same slope. So that is very easy to do because I simply click on the line. And so I clicked on this segment, and so that is this slope here and this slope of this line. So they are both negative 0.57. So they are both equal, meaning that these two lines are parallel. And I can say that they'll always be equal. And I can test that and say, oh, well, since the slopes are going to be the same all the time, no matter what I do to these vertices, then these two lines, these two sides are parallel. But a parallelogram, by definition, is two pairs of parallel sides. So I have one pair of parallel sides right now. And so let's look at the other one, the other pair. And so click on the segment, and then click on this segment to get the slope of those two lines. And so we have that they are both equal to 0.35. And again, let's test that they are always equal to each other, no matter what we do. And they are. They're staying congruent to each other, or their measures are equal to each other. And so we also have that these two, this pair of sides is also parallel. So now I have a quadrilateral with two pairs of parallel sides, meaning I have a parallelogram. And one of the properties of a parallelogram is that its opposite sides are congruent. So then it begins to make a lot of sense that these are congruent and these are congruent, or they have equal measures, because after noticing that, I was able to remember that that is a property of a parallelogram, and then prove that EFGH formed by the midpoints of the sides of quadrilateral ABCD is in fact a parallelogram. And that is all I have. Thank you.